Hi, hello guys, this is Vijay, chemistry lecturer from Aileba Junior College, and as you know that we have started our NEET series based on that we are discussing about NEET chemistry and biological science in detail. So based on this series, we are discussing about the theory part and also we are discussing the NCERT based solutions. Okay, so from this series, today we are going to discuss about Unit 2 atomic structure. Earlier we discussed a few more topics from this particular chapter, and today we are going to discuss about the different atomic models. Let's start. So on this basis, different assumptions of the atomic models by some great personalities. So let us discuss one by one. So first we are going to discuss about J.J. Thomson's model of atom, or J.J. Thomson's atomic model. So what are the salient features of this particular model? Let us discuss one by one. Okay. So according to this, J.J. Thomson's perception of this structure of atom, he got concluded with some salient features, and he could form his own model, atomic model. So in that, the first thing what we are going to discuss is, actually he believed that this atom, which is consists of a uniform sphere shape in which the positive charges which are uniformly distributed. So he believed that the atom, so according to his perception, the atom which consists of the uniform sphere, it looks like a sphere, and where the positively charged particles which are uniformly distributed, and also the electrons which are embedded into in each and every such arrangement, that looks like the most stable electrostatic arrangement. So he believed that the electrons which are embedded in the sphere, the entire uniformly distributed sphere, and based on this, the model of this J.J. Thomson atomic model, that is looks like the budding model or Raisin budding model. So this looks like a Raisin budding model, or it is also said to be watermelon model. It is also said to be watermelon model. So when you look the inner structure of this watermelon, when you cut this watermelon into vertically or horizontal position, the edges, it looks like a sphere, yes, and the seeds which are present in the watermelon, it looks like the seeds are embedded in the empty spaces of the sphere. Similarly, according to this J.J. Thomson's atomic model, he believed that this atom is a uniformly distributed sphere shape, where these electrons which are embedded in the surface of this inner surface of this atom. So he believed in such a way, and this model is popularly known as Raisin budding model or watermelon model. Say for example, in budding, so in that budding also we can see that the raisins will be embedded in the surface of this budding. Yes, so this model also similar to this watermelon model. That is the reason popularly this J.J. Thomson's atomic model is called as Raisin budding model or watermelon model. Okay. Now what are these other characteristic features of this J.J. Thomson's model? The radius of the sphere, which is the order of 10 to the power of minus 10 meter, which is equal to the size of the atom. So the radius, the radius of the sphere, that is the order of 10 to the power of minus 10 meter. The radius of the sphere, that is the order of 10 to the power of minus 10 meter, that is equal to the size of an atom. That is equal to what? The entire size of an atom. Okay, this model also looks like, as I earlier discussed about this budding, bakery items like cake like structure, so where these raisins are embedded in on the surface of this budding structure. Yes, that is the reason it is called as the Raisin budding model. Okay. But when we are talking about this J.J. Thomson atomic model of this raisin pudding model or this watermelon model, the negatively charged particles which are embedded on the surface of the sphere, yes, the uniformly distributed sphere. But later on what happened, this particular model that is discarded. So there are certain reasons this model could be discarded. Say for example, when this Rutherford, when he started doing his alpha scattering experiment, so based on that he could able to postulate some points. So according to this, what happened when he observed the alpha scattering experiment of his conclusion, he observed that some unusual scattering of these alpha particles by the thin metal foil. So that could be able to show that this particular model, where J.J. Thomson's atomic model, that believed that would be discarded, that where these negatively charged particles which are not embedded throughout the sphere, but it is also shown with some different perception by this Rutherford. Okay, so this is about the J.J. Thomson's atomic model. Okay, so now let us discuss about the Rutherford's alpha scattering experiment. Based on that, he could able to give his own postulates of the structure of Rutherford's model of an atom. Let us see now. So now we are going to discuss about this Rutherford's alpha scattering experiment. By through he could able to give his own perception of this Rutherford's model of an atom. So let us see one by one. Actually, this is an experimental setup by which the Rutherford he did this alpha scattering experiment. Okay, so now let us see what are the components present in the experiment first, then after we will go with the experiment. See here there is an lead block, so that lead block that could able to contain inside a radioactive substance that should be bombarded. So when this radioactive substance that is bombarded, that could emit this alpha particle that could able to pass through a thin slate, that slate a thin slate, this is present in front of this lead block, and this is said to be lead shield. Next, these rays which are falling on the emitted alpha particle rays which are falling on a photographic plate, there it could be recorded how far these rays are being emitted from the radioactive substance. Like this screen is made up of zinc sulfide, so that could able to show that the shining of this particular alpha particle emitting rays. So for that purpose this particular chemicals been used, and there is a thin gold foil that placed where this particular alpha particles which is passing through in a straight path, and there we could able to see the emitted rays which are scattered in few rays which are scattered, and some few rays which are penetrated through it and falling on this zinc sulfide screen. And this scintillation, the scintillation is nothing but the the rays which are scattered over that particular process, we supposed to call it as scintillation, and that could be observed by movable microscope used micrometer level objects that can be seen in the movable microscope, and this could be able to observe this observation of scintillation. Okay, so now let us see how Rutherford he did this experiment to prove that according to this J.J. Thomson model of an atom, that is against to his perception. Let us see now. So this particular experiment was conducted by Rutherford and his team, and his two main students of Rutherford, they are called Hans Geiger and Jens Marsden. Okay, and they did as a teamwork for this alpha scattering experiment in the year 1909. Okay, so now let us see how this experiment was performed by Rutherford. Okay, so in his experiment, a particular substance which is placed for a bombarded target of an atoms by these subatomic projectiles, and these projectiles which are called as alpha particles. Okay, and these alpha particles which they were obtained from a radioactive substance, and these alpha particles are highly penetrating power, and also they possesses high energy of positively charged helium ions which are having the charges of +2 and mass of 4 atomic mass unit. Okay, so they used these alpha particles are like helium +2 ion, and it has the mass of 4 atomic mass unit, AMU. Okay. Next, and these particular radioactive substance, when it gets to bombarded, the alpha particles, they could emitted from the radioactive substance on a piece of thin foil of a gold that is placed where these particular alpha particle rays which are passing through. Okay, and in this experiment, the piece of this radioactive substance which is placed in this lead block, that is called radium. So radium is a substance they would used for this performing this particular experiment in the lead block. Okay, now the block which is constructed in such a way that it has a small slit in front of this block, so that the particular beam which is not getting to be scattered throughout, to control that, to pass this beam into a narrow path of these alpha particles that could escape. And this beam of high energy alpha particles was directed by a thin gold foil substance that is placed in the path of this beam. Okay, and the thickness of this gold foil which is taken for this experiment is around 100 nanometer. Okay, so in order to identify the alpha particles after this scattering, there they placed a movable microscope, a movable circular screen coated with zinc sulfide substance apart from this gold foil. When these alpha particles which are striking on this zinc sulfide screen, and they started to produce a flash of light or scintillation which can be observed by this movable microscope. So by examining these different portions of the screen, it was possible to determine the proportion of these alpha particles that could emitted from this radioactive substance. And based on this particular experiment, he could able to form his own perceptions. Let us see one by one what are his perceptions by this particular experiment. So based on this alpha scattering experiment, Rutherford, he could come for the conclusion in that the first conclusion what he observed is most of the alpha particles which is passing through this gold foil which are undeflected. So mostly the rays which are emitted from this radioactive substance which is passing through this gold foil, thin gold foil, which are not undeflected, mostly they started to penetrated, and a small fraction of these alpha particles they got deflected through a small angle. A particular part of this the thin gold foil, few alpha particles they could able to scattered or they could able to deflected, but 99% of these alpha particles when it is passing through which are undeflected, they started to penetrated. So very few they could able to show these deflections. Okay, and these deflections are also showing of this more than 90 degree or even come back suffering of 180 degree. This is the angle they could able to see the few deflected beam that could be seen after when it is passing on this thin gold foil. Okay, so based on this observation, Rutherford could be able to compare with the J.J. Thomson's model of an atom, and he could be able to discard that model of J.J. Thomson, atomic model of J.J. Thomson, and he could be able to show his own observations. So first one is like most of the alpha particles which could be able to pass through the gold foil which are undeflected, but there are very few particles they could be able to deflected. So this picture can very clearly explain about this Rutherford's model of deflections of these alpha particles. So this particular line, that proves that what the most of the part of this particular atom, that is and that has an empty space, where earlier we discussed about this J.J. Thomson's model of atom, the electrons are being embedded as in the form of resin or as in the form of watermelon seeds. So that could be discarded by saying this particular line, most of the particles, alpha particles, could be able to penetrated through this thin metal gold foil, but few only are deflected. So this proves that the electrically charged particles which are not embedded throughout the sphere of an atom. These alpha particles, they are positively charged particles and they have considerable amount of mass, and they can be deflected only if they are coming closer with some heavily positively charged mass which is present inside the atom. That means what? According to this J.J. Thomson model, the electrons are the negatively charged particles which are embedded throughout the sphere. But according to this Rutherford's observation, these alpha particles are directly penetrating through this the sphere of an atom, though it possesses the positively charged, but there are very few positively charged mass which is present inside the atom. There this could be able to be deflected. There is a heavily positively charged mass which is present at the center of an atom, and moreover this mass must be occupying a very small space, and also it could be present at the center of an atom. That is the reason the alpha particles which are possesses positively charged, that could be deflected by this mass which is present at the center. Okay, now the strong deflections are even bouncing back of these alpha particles from the gold foil were explained by this direct collision method with the heavily positively charged mass of the particle present in the atom. Finally, he concluded that this heavily mass particle which is present occupying a small volume at the center of these particular atoms are called as nucleus, and this is supposed to be present at the center of the atom, and that could be able to deflect these positively charged alpha particles. These are the observations and comparison of J.J. Thomson's atomic model by Rutherford and his team. And this chapter we will continue with one more video with further more topic. Until then, thank you guys.